Welcome to Lesson 1-4, Estimating with Decimals and Whole Numbers. Today we're going to talk about rounding decimals to the nearest whole, the nearest tenth, the nearest hundredth, and the nearest thousandth. We're also going to use rounding to estimate sums, differences, products, and we're going to use compatible numbers to estimate quotients. All right, so first we're going to talk about vocabulary. When we say estimating, a lot of students automatically think of rounding. Well, rounding is a type of estimation. So if you think of it this way, so think of an umbrella. And you have this umbrella, and it's estimation. Everything under the umbrella is a type of estimation. So rounding is a type of estimating, and compatible numbers is a type of estimating. So rounding and estimating don't mean the same thing. Estimating an answer means that you're taking a guess at an answer. You're getting close to it. You're not finding an exact answer, something close. And rounding is how you would do that. Or compatible numbers are how you would do that. Right, so we have to get out of this habit of using rounding and estimating interchangeably because they are not the same. So with rounding, the definition is to change a number to a more convenient or easy to use value. For example, we take 153, and if we round it to the nearest 10, we say we have 150. Or if we have 1 and 53 hundredths, we can round it to the nearest tenth and say that we have 1 and 5 tenths. Okay, so rounding is when we make those numbers shorter or we make them nicer numbers to work with. When you're rounding, make sure that if it tells you to round to the tenths place, that that's where your number ends. We'll talk about that a little bit more, but you'll notice here that my number went to the hundredths, and then I rounded it to the tenths, and I got rid of that 0. Okay, we want to get into the habit of getting rid of the 0 instead of keeping it when we're working with decimals. All right, compatible numbers. Compatible numbers are numbers that are easy to compute mentally. So you're not necessarily rounding, you're using your multiplication facts to put numbers together that are easily computed mentally. Okay, so numbers that work well together, like friends. So when you talk about being compatible with somebody, you work well with that person. So think about numbers that work well together when you're dividing. Do they work well together if they give us a remainder or a decimal or a fraction? No, they work, but not as easily as we'd like them to. So compatible numbers are numbers that work well, and that means that they don't give us a remainder when we divide. So for example, 10 and 2 would be compatible numbers. Okay, because I know that I can divide 10 by 2 and get a nice whole number. All right, so estimating with decimals. When we talk about estimating with decimals and decimals in general, what is the most important piece of being able to work with decimals? If you said place value, you are absolutely correct. You have to know your place values. Remember, the place value tells you the place, so where it is, and the value tells you how much it's worth. So if I ask you for the place value, I'm asking where is it? If I ask you for the value, I'm asking how much is it worth? Right? And then notice after the decimal, everything has a th after it. And remember that after the decimal, it's like having a fraction. So we don't have a oneths because anything over 1 is a whole number. Okay, so we don't have whole numbers behind the decimal, so there is no oneths place. All right, so let's go ahead and keep this in mind as we go to the next page. So we're going to estimate the sum, difference, or product, or quotient. So up here it tells us it wants us to round to the hundredths. I know that this is helpful for us, so I'll use it again. We want to round to the hundredths place, so I look at my decimal. I have the THS, so I want to go to the right of my decimal. And if I'm not sure, make sure you write this down. But the hundredths place is 2 places after the decimal. So I look at the number that's 2 places after the decimal, which is the 3, and I put a dot underneath it, and everything else goes in the box. Again, I come over here, 9 is in the hundredths place, I put my dot, and everything else goes in the box. That first number inside the box tells that dotted number what to do. So since the 8 tells the 3 to go up, I know that my 14 will stay the same, my 2 will stay the same, but my 3 turns into a 4. Now typically what we do is we put zeros, so everything in the box turns to a 0, but we want to take and make this rounded to the hundredths, because right now this is 14 and 2,410 thousandths. If they want you to round to the hundredths, then your answer should say hundredths. So to make this answer with hundredths, I have to take off these 2 zeros and make it 14 and 24 hundredths. So you can do this step if it helps you, or if you can just eliminate the zeros right away, go right ahead. Alright, so here the 8 tells the 9 to go up. Well, that means that the 9 is going to go up to a 10. So this is going to become a 0, but I can't put a 1 and a 0 in the same place value, so I have to carry that 10 over to the 4, and so the 4 is going to become a 5. So my 3 stays the same, my 4 changes to a 5, my 9 changes to a 0, and my 8 changes to a 0. Okay, so then what I do is I want it to end in the hundredths place. So this time I am going to end up keeping one of my zeros. So it's 3 and 50 hundredths. And then I can go ahead and add. So I don't add and then round, because that's not estimating your answer. Estimating your answer means that you round or use compatible numbers beforehand. If you round afterwards, you already found the exact answer, and then you're going away from that. And that doesn't make much sense, because when you estimate, you're trying to have an estimate so you can say, you know, does your answer make sense when you find the exact answer? So in this case, I have 4 plus 0 is 4, 2 plus 5 is 7, 3 plus 4 is 7, 1 plus 0 is 0. So my estimated answer to the hundredths is 17 and 74 hundredths. When you read your answer, if it doesn't end with this word or the word that you're rounding to, then something is wrong and you haven't rounded correctly. Alright, so now I'm just going to go through and I'm going to do these with you. I'm not going to do so much explaining. So the dot goes under the 7 because it's in the tenths place. The 9 tells the 7 to go up. So I know I have 19 and 8 tenths minus 8 is in the tenths place. The 4 tells the 8 to stay the same. So I have 2 and 8 tenths. 8 tenths minus 8 tenths is 0. With the decimal, 9 minus 2 is 7. And I know that 19 minus 2 is 17. So my answer is 17 and 0 tenths. Okay, now don't get rid of the 0. I know that we've talked about making our numbers nice and just getting rid of these extra zeros if we don't need them. But because you want your answer to end in the tenths place, you want to keep that 0. Now we're looking at the nearest whole number. So the nearest whole number in this case means that you're rounding to the ones place. So 9 is in the ones place, and 8 and 9 go in the box. The 8 tells the 9 to round up. So I know that that'll become 10, and I have to carry the 1, so 19 becomes 20. And then now I don't put any decimals afterwards because I'm rounding to the nearest whole number. Again, I'm rounding to the nearest whole number, so I have 1. The 7 tells the 1 to turn into a 2. And that's it. So I know 2 times 2 is 4. With my extra 0, I add a 0 to the end. So 20 times 2 is 40. And then now we're going to do round to the tenths one more time. So I have 3 is in the tenths place. The 4 tells the 3 to stay the same. Divided by, well, the 0 tells the 2 to stay the same. I'm just now getting rid of that 0. And then now I know that I have to move my decimal once to the right, once to the right. So I have 12 on the outside. And then I have 363 on the inside. 12 goes into 36 because it can't go into 3. Goes into 36 3 times minus 12. I'm sorry, minus 36 is 0. Bring down the 3. 12 goes into 3 0 times. So I add a decimal, add a 0, so I add a box. 12 goes into 30 twice. Now I need to add another 0, and let me move this over so that way we can see everything here. I'll move it up a little bit. There we go. So since I add another 0, I have to add another box. Bring down that 0. I know 12 goes into 60 5 times. 12 times 5 is 60. I subtract and I get 0. So my estimated answer is 30 and 25 hundredths. All right, so now my answer ends in the hundredths. So I can, because I rounded to the tenths, it kind of depends on what you're looking for. You could leave this, or you could say, okay, my answer, I should round it again. My answer should be somewhere around 30 and 3/10. Okay, so notice when we divided, even though we rounded to the tenths, we ended up with an answer that went to the hundredths. This happens a lot when you end up multiplying and dividing. So that's why we use compatible numbers when it comes to division. And we'll do this with, you can do this with decimals as well, but we're going to focus on whole numbers. So with compatible numbers, you really need to know your multiplication facts. So 36 and 11. When you use compatible numbers, you want to change just one of the numbers, and you want to make the smallest change that you can. So here, I know that 36 is compatible with 12, and 12 is 1 away from 11. So the compatible numbers here would be 36 divided by 12. So I know my answer should be somewhere around 3. Again, I could also say that 36 is close to 33, which is divisible by 11, and that's going to tell me also that my answer should be around 3. Notice I didn't go to 30 and change this to 10 or go to 40 and change this to 10. No, just change one number. All right, so 48. I know 48 is divisible by 8, so I change my 7 to an 8. And 48 divided by 8 is 6. Or I could change the 48 to 49, which is divisible by 7, and know that my answer should be somewhere between 6 and 7. Okay, so since you made your divisor bigger, when you make your divisor bigger, your quotient is typically going to get smaller because you're putting more into each group. So if this is the case, then you're underestimating. Here I made my dividend bigger, and so I'm overestimating. So you really want to be careful with which one you use. Typically, I'm just going to ask you to do compatible numbers, but if you're using them, and say you're trying to plan for a party or something like that, you wouldn't want to make your divisor higher and underestimate, because then you might not have enough of what you need for your party. So keep in mind when you're estimating whether you want your estimation to be higher or lower, or you could do both. And so here we said, okay, our answer should be somewhere between 6 and 7. Here we said that our answer for both of them was 3. So we know that our answer should be fairly close to 3. All right, 17 divided by 3. Again, I could take the 17 and turn it into 18, which I know is divisible by 3. 18 divided by 3 is 6, so I know my answer should be around 6. But then here, 17 is a prime number. So I can't change the 3 to anything else but 1 to make a compatible number. So in this case, this is your only option, the 18 divided by 3. So sometimes, as long as you know that the dividend is a prime number, sometimes you only have one option. And these estimations, like I said before, tell you what your answer should be around, or what it should be close to. All right, so after all that, you have 5 problems that I'd like you to try on your own. I want you to round and find your answers, and then use compatible numbers and find your answers or find your estimates. And as always, if you have any questions, make sure to email me or write them down so we can talk about them in class.